So this is the second video, second part. We're on the back side. It says practice makes perfect. The instructions say rewrite the following in exponential form, similar to homework questions 13 through 18. So what we're going to do is look at log base 8 of 64. Now, if I just gave you that and I told you find the answer of this, what you need to know is how to rewrite it in exponential form, how to think of it in exponential form. The base is 8, so that's really 8 to what power gives me the answer 64? 8 to what power gives me 64? 2. Now, this is ridiculous because they already give you the answer. There it is. The answer is 2. All they want you to do is to change the original logarithmic form that already has the answer into your exponential form. So your answer right there is 8 to the second equals 64. So you're not even thinking. You're not even doing any math here. All you're doing is rearranging things, right? Like on number 2, how are you going to rewrite that? 5 to the third power equals 125. I guess the key thought here is the base of your log will be the base of your exponent. That's what I meant to say. Okay, the base of your log will be the base of your exponent. So your base is 5 right here. When you write it in exponential form, your base is going to be 5, not the exponent. So the base is 5. Your exponent, if you want, leave it blank for a while. You know your answer has to be 125. So 5 to what power gives you 125? We already have the answer here. It's 3. So it's 5 to the third power equals 125. So on all of these, it's just a question of rearranging. And the best phrase for you to keep in mind what you're doing is that the base of your log will be the base of your exponent. Okay, so you could do all those. How about number 8? Log base 7 of 7 equals 1. Rewritten in exponential form, what will it be? 7 to the 1 power equals 7. Cool? All right. So I think you guys could do all these on your own, right? Number 3. What would that be?
4 to the power of 5 equals 1
Equals 1024. That's right. How about the next one?
13 to the third power equals 2,197.
Whoops, forgot the 2. 2,197. You see, it's cake. All right, let's move on. Check out this bottom part. This is where it gets fun. It says, evaluate the logarithm. So notice right here, they don't give you the answer. We actually need to think. And the only way to think is to be able to understand how to rewrite it in exponential form and think about it in exponential form. So, number 1, what it's really saying is 2 to what power will give me 4? What do you guys say?
2.
Hey, the answer is 2. Done. Right? So the answer is 2. And that's it. You don't even need to show this. Now, let's say somebody asked you, why is the answer 2? Then you could say, oh, because 2 squared is 4. Okay, that's really the explanation of why your answer is 2. How about number 2? The answer is 4. And if somebody asks you why, you're going to say, oh, because 2 to the power of 4 gives me 16. Okay? How about the answer number 3? 3 is the answer. Okay? You don't even have to mention exponents. The answer is 3. The answer number 4? 2. Okay, so we're getting the hang of this, right?
Yeah.
Now if somebody says, why is the answer 2? I don't get it. Why is the answer 2? You're going to say, because 9 to the power of 2 is 81. You're going to explain to them, well, this base is the base, and you're thinking 9 to what power gives me the 81? Oh, the answer is 2. That's why over here the answer is 2. You don't need to show this work. This is just the explanation. Unless they ask you, rewrite your logarithmic form to exponential form, then yeah, you want to write this. But this is just the understanding of why the answer is 2. The explanation. How about number 5? What's the answer? 3. Piece of cake. How about number 6? What's the answer? 1. 3 to the 1 is 3. Perfect. Okay, how about number 7? 0. Easy. How about number 8? 2. Because 7 squared is 49. Piece of cake, right? Logarithms are easy. Next? 1. The next one? 0. Number 11. 1. Again, 12 to the 1 power gives you 12. So the answer is 1. And now we finally get to something more fun. 1, negative 1.5. What's going on? Who knows? In order for this to make sense to me, the 0.2, that's not working for me. So I'm going to change the way it looks to make it more appealing to me. The 0.2 is really read as 2/10, right? And 2/10 is really a fraction that could be reduced to 1/5, right? So in reality, this is saying log base 5 of 1/5 equals. That's what it's saying, right? And now you could think about it in exponential form and say, okay, the base is 5, so I have the base 5 to what power gives me the answer 1/5. So what would this power be? That would be -1, guys. 5 to the -1 power will give you 1/5. So your final answer up here is -1. That's your answer. This is the whole explanation, thought process of how we get -1 as an answer. So if you have a decimal, you might want to change it to a fraction to make it more understandable. Number 13, let's change that decimal to a fraction, and I'll really have log base 2 of what? If you went, this is the 10th position, this is the 100th position, you really have 25 hundredths, but 25 hundredths reduces down to what? 1/4. So I really have log base 2 of 1/4. So if I think about exponential form, the situation with exponents, you have 2 to what power gives me that number 1/4? That's right, the answer is -2. So over here the answer is -2 and we're done. You see, it's easy. Let's look at something more fun. Yes, it gets more fun. Number 14, log base 1/3 of 9. Let's think about it in exponential form. I like to write it down. What's my base going to be? The same base, 1/3. So logarithm to exponential form is the base, there it is, to what power gives you that answer 9? -2. Because the negative causes the fraction to flip and it becomes positive and you have 3 squared, which is 9. So the answer is -2. Do you need to show all this work? No, but I recommend you do it, especially right here at the beginning. I always show my work on these guys. Moving on. How about this guy? I want to have 1/5 to what power gives me 125? -3 is your answer. How about the next one? This one's interesting. The base is 64, guys. To what power will give you 8? There you go. 1/2 is the answer. Why 1/2? Because the power of 1/2 is really the square root. So the answer is 1/2 right here. So moving on to number 17, you could rewrite it as exponential form so you could think about the answer. 4 to what power will give you 2? 4 to what power will give you 2 as an answer? Again, it's 1/2 because the power of 1/2 is a square root, and the square root of 4 is 2. So the answer is 1/2. Okay? How about number 18? Log base what? It's base 10, right? Because it's a common log. Or I could have read it common log of 100. You could write the 10 if you want. Common log of 100 is what? What's the answer? 2. Why? You don't need to do this, but if you want to explain to somebody why the answer is 2, that's because 10 to the second power gives you 100. That's why the answer is 2, right? Let's look at this one. Number 19, common log 10. What's the answer? 1, that's right. If I said, why is the answer 1? Well, because this is a common log, which means that it has base 10. Sorry, my voice. Okay, so common log's base 10. So if you have the base 10, to what power gives you 10? Oh, the answer is 1. That's why the answer is 1 right here. Okay. Moving on, number 20. Now remember, ln is really what? That's a natural log, but what are natural logs really, according to our notes? That's log base what? base e of e. Are you with me? Now, what is that answer going to be?
E.
What is e to what power will give you e?
1.
1, right? E to the power of 1 will give you e. So this answer is 1. Now, this is very important. This is very important a section right here that we need to recognize. Because when you have log base e of e, it really just cancels out and the answer is 1. Now, check this out. Likewise, if you had log base 2 of 2, what does that equal?
1.
It cancels out and it equals 1. What if you have log base 5 of 5? What does that equal? 1. It cancels out, equals 1, right? What if you have, it doesn't matter what you have. You could have log base 1/3 of 1/3. And what does it equal? 1, because it just always cancels out. Whenever you take the log base something of that same something, it cancels out, it equals 1. I mean, it doesn't matter what it is. Log base happy face, that's an ugly happy face, of happy face, what does it equal?
1.
That equals 1. Because log base happy face of happy face cancels out, it equals 1. Go on. So once again, whenever you take the log base something of that same something, it's going to equal 1. We just did log base happy face of happy face equals 1. Even this one, log base Mr. Salgado of Mr. Salgado equals what? 1. That's right. Okay? This cancels out and it equals 1. Whenever you have the same thing as the base and the same thing that you're taking the log of, then it's going to cancel out and equal 1. Okay? I hope that helps. So with that fact, we're going to be able to move on to this portion over here. It says simplify. How about log base 13 of 13?
1.
That's 1. That's right. 1. How about the next one? Log base 5 of 5x.
1.
Now see right here, it's a little different. There's an x up there, right?
1x.
So the log base 5 of 5 cancels out, disappears, and the answer just comes down as x. There's no more x. The x is no longer an exponent, it comes down. Because log base 5 of 5 cancels out, the x just comes down. Something that we need to learn. And right here, likewise, 3 to the power of log base 3. See, what we need to learn and understand is that a logarithm is the inverse of a power. A logarithm is the inverse of a power. So when you have, it's kind of like saying when you do a square root squared, the square root cancels out. Right here, the 3 to the power of log base 3, that also cancels out, and your answer is x. Okay? So let me repeat that. The logarithm is the inverse of an exponent. An exponent is the inverse of a logarithm. Number 4, 10 to the power of common log 4. What's the answer there?
1.
That cancels out and the answer is 4. Because it's really common log of 4. So the 10 to the power of log base 10 also cancels out. So this is all because they're inverses of each other. A logarithm is the inverse of an exponent, and exponent is the inverse of a logarithm. As a matter of fact, on this next video, we're going to flip back over to finish the rest of the notes when it comes to inverse of logarithmic functions or inverse of exponential functions.